My name is Viktor. I will not do a demo, which is what I tend to do all the time, because I think that's the cool part of everything. Instead, you will be seeing my pretty face for 20 minutes or something like that, right? So what are we talking about, right? You're using AWS. You already know more or less what it does. It creates infrastructure for you. It manages your applications and so on and so forth. What I want to focus right now is Kubernetes, for a simple reason, because you are using Kubernetes, or you are thinking about using Kubernetes, or you might have it in your labs and planning to use Kubernetes, but everybody's jumping on that train and you must be one of them. So I will focus on the application, not the infrastructure, but the application side of the story. And that's a side of the story that comes after you create, let's say, your EKS cluster. You're probably using EKS Cattle, or you're using CloudFormation or something like that. You create your cluster, you set up your kubectl to communicate with that cluster, and then you start wondering, what do you do next? And what do you do next is basically deploy your applications, right? That's the logical next step. And there are a couple of things that absolutely everybody wants to accomplish when dealing with applications. You want to make it easy because you don't want people to spend months trying to figure out, especially in Kubernetes world. It's very complex. You don't want to spend months, everybody to spend months trying to figure it out. You want to make it fast because absolutely every single minute that people are waiting for something instead of doing whatever they're doing is a huge waste. You want to make it repeatable so that whatever you're doing, and let's start there actually, almost every 50% or 90% of what we're doing is repeatable stuff. It's not really creative. These are not really creative things, mostly because we spend too much time on things that are dull, that are repeatable. So we want to make repeatable processes. We want to make them reliable. We want to make them traceable, and we want to make them secure. Absolutely every company in the world that I know of wants those things. And how do we get there, right? A couple of very important things to do. And first thing that you want to do is to remove humans from everything you're doing that is repeatable, right? So humans out of the picture, because it's a huge waste of brain capacity to have 1, 10, 100,000 people running scripts over and over again, executing same stuff over and over again. People are supposed to be creative because that's what they're good at, and we express that creativity by writing code. And machines are good at being repeatable and reliable and what's not, and we let them do those things. So the first step, remove completely humans. I was supposed to show you how to do that through pipelines, in this case, Codefresh pipelines. But in essence, what we do is you define the steps and say, hey, whenever I push something to a Git repository, then this should happen, and that should happen, and that should happen, and what's not should happen, right? Remove the automated repeatable tasks by creating pipelines. And then we need to start dealing about being traceable. And traceability today is accomplished through GitOps, right? If you're not familiar with GitOps, basically GitOps is something that we've been doing for like 20, 30 years. I mean, when I say we, some of us were doing for many, many years, but it's a new term that enforces something that we should all be doing. And that means that everything, absolutely everything we do is defined as code, and code is stored in Git. And if everything is code and all the code is in Git, that means that Git becomes the source of truth for absolutely everything you have. And that means that you are not going anymore to some console, to some web UI, you're not executing random scripts, you are defining absolutely everything as code. And that means that either you're using Terraform or EKS Cattle, and when I say EKS Cattle, I don't mean EKS Cattle create cluster, I mean EKS Cattle create cluster. This is the definition of my cluster stored in Git, or CloudFormation, or what's not, right? So GitOps is becoming the fundamental part of absolutely everything that almost everybody is doing today, whether they know it or not. And we have tools now at our disposal to make that simpler. And those tools, at least the most prominent tools we have today to deal with deployments to, in this case, EKS cluster, Elastic Kubernetes Service Cluster, would be either Argo CD or Flux. In my case, I'm focused much more on Argo CD simply because I'm more emotionally attached to it. So what it really does is that instead of you accessing your cluster, accessing your EKS cluster with kubectl or through SSH or whatever you're doing today, you're having an agent inside of your cluster, and that is the first and the last thing you will ever install in your cluster. From there on, that agent is sitting there and monitoring one or more Git repositories that you specified, and that's where you're pushing changes. You want to have your cluster to communicate with one of the databases that you heard in the previous talk. Excellent. Create a manifest configuration for whatever you're having, push it to Git, and let, in this case, Argo CD pull that information and do whatever needs to be done with it. You, my dear listener, user, you are not supposed to access any of the servers ever, except something is burning or some terrible disaster is happening, because you are unreliable. You cannot do the same thing over and over again, and so on and so forth. And we want to have the trace of everything that is happening, and that trace we are doing by defining the desired state, stored in Git, and letting the machines, in this case, some type of GitOps agent, Argo CD, for example, listening to your changes to Git repository and doing whatever needs to be done to make your desired state become the actual state. So nobody has access to servers, nobody has access to clusters, nobody has access to infrastructure, nobody has access to any of the things you have in AWS except an agent that is fulfilling whatever are your desires expressed as code and stored in Git. That's the general rule. That's the general gist. What else? And then we need to make sure that that something is, I already said, traceable. We get traceability by comparing the desired and the actual state, and we need to make sure that that's secure. And for that, you have a bunch of security scanning tools that will, quite a few in AWS portfolio, that will validate, make sure that whatever you are doing right now is safe to be doing. And how do we trigger those tools? Again, not by executing commands on your laptop, not by going to the UI and clicking whatever, by those same tools running in your cluster, the process is running in your cluster, creating events and sending those events to whichever tools are supposed to do whatever type of scanning, and then receiving another set of events back from those tools, and maybe doing something like notifying you that you did a terrible mistake and you made a huge security hole and whatever you just did that you shouldn't be doing. So, and then finally, once we do all that, once we remove humans from the processes, once we remove people from accessing any part of your infrastructure, and once we make sure that that something is secure, the only thing left is really to reduce the blast radius when things go terribly wrong. And trust me, things go terribly wrong more often than we want. And the only way to reduce the blast radius is by doing some way of progressive delivery. And that progressive delivery can be on a level of infrastructure or on a level of applications. What really matters about it is that when you make a change, you make the change to 1% of the users, or maybe 10% of the users, and then start gradually increasing the reach of that something as you're increasing the confidence that that something works. Like, let's say you're upgrading your EKS cluster, you will upgrade a single node of that cluster, start monitoring metrics through CloudWatch or whatever you're using, Prometheus maybe, whatever you're using to store the metrics, say, hey, my users are still having a positive experience with this change of upgrading a single node of my cluster or upgrading a single replica of my application. I should continue that trend. I should scale it up to 2, 3, 4 until you get to 100%. And again, when I say you, I actually do not mean you. because as I said already before, you are supposed to write code, you are supposed to do creative stuff. I mean that you're having processes that are doing that. That can be, from top of my head, it could be Argo rollouts, it could be, what else is there? Flagger, for example, or any of the tools that are designed basically to do progressive delivery in form of canary deployments, blue-green deployments, or even if you don't want any of those tools, out of the box, you're already getting rolling updates, even though you might not be aware of it, except that rolling updates require, actually do not require much, but are hardly unreliable because they cannot really hook into your metrics and make decisions by themselves. And that means that you're getting back to be involved, which is a terrible, terrible, terrible idea. And finally, once we reduce the blast radius and we can affect negatively in case that the bad things happen only a fraction of our users, the last thing we're missing is to automatically roll back. And that's the same logic with the same set of tools that I made, progressive delivery tools usually, that will monitor those same metrics and say, hey, people are having negative experience, the latency increased, the error rate increased, or whatever you're monitoring, whatever you're measuring, and that some negative trend is happening repeatedly over a certain period of time and is repeating over a certain number of iterations. Therefore, the only thing left for me to do is to roll back. And how do I roll back? By pushing change to Git, because remember, you don't have access to your cluster anymore after this talk. Pushing change to Git and letting the tools, CloudFormation, EKS Cattle, pipelines, Argo CD, what's or not, do the rollback by basically applying the previous commit that you made over there.